Ever wondered how giants like Google and Amazon manage their sprawling data landscapes? The secret lies in the art of organization. In our data-driven world, organization and information models are not just tools but essentials. These models provide structured frameworks that help in organizing and representing data effectively. From hierarchical to object-oriented, each model offers unique advantages tailored for specific needs and scenarios. They are the skeletons that support the vast body of data that businesses like these handle daily. Understanding these models is not just for IT professionals, but for anyone dealing with data in the digital age. Dive into the world of organization models where data finds its structure. First up, we have the hierarchical model. Picture an organizational chart with a CEO at the top and various departments branching out below. This tree-like structure is not just for organizational charts. It's also fundamental in managing file systems and directory services. Each node or data element has one parent and can have multiple children, establishing a clear and straightforward lineage. Next, let's explore the network model. Imagine a social network where each person can have connections or links to multiple other people, forming a complex web of relationships. In the network model, data is organized as records connected by these predefined relationships. Unlike the hierarchical model, each record can have numerous parent and child records, enabling the representation of more intricate interconnections. This model is particularly useful in database management systems where complexity is key. Moving on to the relational model, which is the backbone of many applications we interact with daily. Think of an online store's product listings, where each product, its price and category are organized into tables that can be searched, sorted, and linked to other relevant data. The relational model uses tables, rows, and columns to manage data, and relationships are established through key attributes, making data operations both intuitive and efficient. Then there's the object-oriented model, which mirrors the way software developers think and work. In this model, data is encapsulated within objects that not only contain data but also behavior, methods that define what the data can do. This model supports inheritance, allowing new objects to take on properties of existing ones, which promotes reusability and modularity in software development. Lastly, we have the NoSQL model, a hero in the era of big data and real-time web applications. NoSQL databases, such as document-oriented or graph-based ones, are designed to handle vast amounts of unstructured or semi-structured data. They offer tremendous flexibility and scalability, making them ideal for applications that require rapid processing of diverse data types. Each model offers unique advantages depending on the complexity and type of data involved. Transitioning from how we organize data to how we conceptualize it, let's delve into the diverse world of information models. Starting with the Entity Relationship Model, or ER model, this approach is a cornerstone in database design. It visualizes entities, essentially objects or things of interest, and the relationships between them. For instance, in a university database, entities could include student, course, and instructor, with relationships such as enrolls in or teaches. This model helps to lay out a database in a clear, logical format, where entities become tables, attributes become columns, and relationships are expressed as foreign keys. Next, we encounter the Unified Modeling Language, widely known as UML. This is not just a model, but a rich language for specifying, visualizing, and documenting the components of software systems. UML encompasses a variety of diagrams, such as class diagrams for showing the structure of systems, or sequence diagrams that detail the interactions over time. Imagine designing a software system where UML acts as the blueprint, illustrating every aspect from architecture to processes. Moving on to data flow diagrams, or DFDs. These are immensely useful in understanding and analyzing system structures. They show how data moves through a system, from inputs to processes and then to outputs, highlighting the system's functional flow. For example, in a retail management system, a DFD could illustrate how customer data flows from point-of-sale terminals to inventory and billing systems. The ontology model takes a slightly different approach, focusing on the representation of knowledge rather than data alone. In fields like artificial intelligence and semantic web technologies, ontologies help machines to understand and process complex concepts and relationships within a specific domain. Lastly, we look at XML and JSON, pivotal in data interchange. XML, or Extensible Markup Language, structures data in a flexible, hierarchical format, making it ideal for complex data arrangements. JSON, or JavaScript Object Notation, offers a lightweight text-based format, favored especially in web services for its ease of use with JavaScript. These models help in visualizing, designing, and communicating complex data relationships and flows. Let's put theory into practice with some real-world applications. In the bustling world of retail, a large chain store exemplifies the power of the relational model. This retailer manages an extensive inventory across hundreds of locations worldwide. Each item in their inventory is stored in tables that detail product categories, stock levels, supplier information, and pricing. The relational model's strength lies in its ability to handle vast amounts of structured data with ease, allowing for complex queries that can, for instance, instantly reveal which products are understocked across their global network. Switching gears to the fast-paced tech industry, consider a dynamic tech startup that utilizes a NoSQL database to cater to its diverse and voluminous user data. This startup, specializing in personalized content delivery, employs a document-oriented NoSQL model. This model is adept at handling semi-structured data like user preferences and interaction logs, enabling the system to scale dynamically and maintain high performance even under the load of millions of active users. The flexibility of NoSQL allows the startup to iterate rapidly on its product without being constrained by the rigid schema of traditional databases. On another front, a government agency demonstrates the practical application of the Unified Modeling Language, or UML, during a major system upgrade. Tasked with enhancing their public service delivery, the agency used UML diagrams to map out and refine processes. Class diagrams were particularly useful in illustrating system entities and their interactions, which helped in identifying redundancies and streamlining operations. The visual aspect of UML facilitated clear communication among diverse teams, ensuring that everyone, from developers to department heads, was aligned with the system's goals. Real-world applications show the practical benefits and challenges of each model. Each model serves distinct needs, from managing vast arrays of structured data in a retail giant to accommodating rapid changes in a tech startup or ensuring clarity and alignment in government operations. These case studies illuminate not just the theoretical strengths, but also the tangible impacts these models have in various sectors. With so many models, how do you choose the right one? Selecting the appropriate organization or information model is crucial and can significantly impact the efficiency and scalability of your system. Let's explore some key factors to consider when making this decision. Firstly, consider the type of data you're dealing with. If your data is highly structured and transaction-oriented, the relational model might be your best bet due to its robustness in handling complex queries and maintaining data integrity. On the other hand, if your data is more varied or unstructured, such as large volumes of web data or social media interactions, a NoSQL model might be more appropriate, providing the flexibility that traditional relational databases lack. Scalability is another critical factor. For applications that need to scale dynamically and handle massive amounts of data, NoSQL databases like document-oriented or key-value stores offer superior performance and easier horizontal scaling compared to traditional relational databases. Complexity of data relationships also plays a pivotal role. If your application involves complex data relationships and you need robust data integrity, the network or object-oriented model might be suitable. These models provide more sophisticated structures to manage nuanced relationships more effectively than a simple hierarchical or relational model. Lastly, consider your specific use cases. For instance, if you're developing a real-time application that requires rapid access to data, a key-value NoSQL model could provide the speed you need. Conversely, For applications requiring detailed analytics and reporting, the relational model's strong query capabilities might be indispensable. The right model aligns with your data needs and business goals, optimizing both performance and manageability. We've explored a world where data structure and conceptualization govern its utility and power. In our journey, we've uncovered the intricate landscapes of organization and information models, each uniquely tailored to meet specific needs and challenges. The hierarchical model, with its tree-like structure, offers simplicity and a clear, straightforward hierarchy, making it ideal for applications like organizational structures and directory services. On the other side, the network model allows complex interconnections, supporting multiple relationships and enabling a more flexible approach to data management. Then we transition to the relational model, celebrated for its use of tables, rows, and columns. This model's strength lies in its ability to establish relationships through key attributes, making it a staple in database management due to its simplicity and flexibility. Meanwhile, the object-oriented model encapsulates data and behavior into objects, fostering modularity and code reuse, essential for applications developed in languages like Java and C++. Not to be overlooked, the NoSQL model breaks the traditional relational database mold to address the needs of handling large volumes of unstructured data, thus offering significant advantages in scalability and performance for specific applications such as big data analytics and real-time web applications. On the information model front, the entity relationship model provides a conceptual blueprint for relational database design, simplifying the complex relationships between data elements. The Unified Modeling Language, or UML, offers a standardized approach to visualizing and documenting system structures and behaviors, which is crucial in software development. Data flow diagrams help in mapping out the path data takes through a system, ensuring efficient processing and identifying key data interactions. Finally, ontologies and structured data formats like XML and JSON play pivotal roles in knowledge representation and data interchange respectively, aiding in the seamless integration and comprehension of data across different systems. Understanding these models is not merely an academic exercise. It is crucial for making informed decisions that align with strategic business goals. The choice of a data organization or information model impacts everything from operational efficiency to innovation capacity. Choosing the right data organization and information model isn't just an IT decision, it's a strategic business decision.